Hello, and a very good afternoon to all of you here. I am Pallav, and it's my pleasure to welcome you all on behalf of eMobility Plus and First View Group. Our today's webinar, which is on leveraging digitalizations in EV manufacturing, brought all of us together on this common virtual platform to gain insights on the current state of digitalizations in the automotive industry and the progress, especially with regards to the design, simulation, and manufacturing of vehicles and their important components. So, without losing any precious time, it's time to start the panel discussion. And for this, we are honored to have with us Professor Praveen Kumar from IIT Guwahati will also be moderating the session. Dr. Dev Mukherjee from Omega Seki Mobility, Mr. Sameer Kumar Mishra, JBM Group, Mr. Varat Krishnan Rao from eMobi Manufacturing Private Limited, and Mr. Mahesh A. Patwardhan, Automotive Research Association of India. But before handing over the session to Professor Praveen, I would like to make a small announcement here for all our attendees. If you have any questions during the discussion, please post them in the Q&A box. Our panelists will take those questions at the end of the discussion. So now I would like to welcome all our esteemed panelists on screen and request Professor Praveen to lead the discussion. Over to you, Praveen, sir.
Thank you, Mr. Rana, and good afternoon to everyone, the panelists and the audience. Thank you for joining us this afternoon. So, as we know, we are about to start this discussion on a very special theme, which is leveraging digitalization in EV manufacturing. And as we see that India is gathering steam in EV adoption, so this becomes a very, very important topic. So for today's afternoon discussion, I would set the format that all the panelists would speak for 5 minutes, followed by a question from my end, and at the end we will open the floor to the audience for their questions, and the experts would be answering them. So I think with this in mind, I would first request Dr. Dev Mukherjee to share his ideas with us and with the audience at large. So, Dr. Mukherjee, thank you very much. I hand over the floor to you.
Thank you very much, Professor Praveen. It's great to see you again. And good afternoon to all my fellow panelists. And thank you, Pallav, for having me. It's a pleasure to be on this panel. So the topic is very interesting. And, as we all know, now electric vehicles are being talked more and more in the context of mobility. Energy and connectivity. So and everything is coming together in an integrated manner. And we are talking about Industry 4, where the whole all the energy, all the technologies are getting integrated in a way that it becomes a complete energy universe, as I call it. And mobility or automobile is a part of this universe. It is not just a transportation device anymore, but it is part of the whole energy ecosystem. So in this ecosystem, if we talk about and what digitalization will play the role, my views are that see, if we talk about the product design, process design, manufacturing engineering, etc., the even in the era of IC engines, these were the tools were there. We used to do the design using CAD, CAM, etc., and simulation tools were there. In the context of EV, uh, the product specific digitalization becomes important, because EV calls for certain specific uh, design capabilities, simulations, etc. For example, batteries. Now, batteries, you have to do the thermal simulation, battery behavior, life, charging, etc., etc. So all that comes into play. Similarly, the powertrain again is a very EV unique product, and here you have to, see the behavior of the motor, energy consumption, efficiency, etc., in the whole package of the vehicle. So this is where I think I'm talking in the context of product, the specifics emerge, and we have to use digital tools. Now digital twins are coming, and all these new technology in the metaverse are coming, wherein you can cut short the product development time significantly. So I see that there are two specific requirements. One is the accuracy of the simulation, how close it is to actually simulating the product behavior. For example, battery life is being talked about now, from 3 years to 10 years, 15 years. So how do you do that, and how accurate the results are going to be? So that is something. The accuracy of the simulation is important. And second is the whole time taken to cut short the product development is going to become very, very important. So this is where the whole the role of these digital twins and digital tools and technologies will come to the fore. And I do see that this will not be limited only to the product or the process design, but the entire supply chain will get digitized. I think this is something which we are going to see more and more, right from the product development to product approval, validation, to manufacturing, and then the managing the customer and the forward linkage of when the product goes to the market. And then another important the facet of this supply chain is coming, particularly in the EV era, is the end of life treatment. How do you treat the batteries, for example, etc. So this entire supply chain with various stakeholders will get digitized, and you can access huge amount of data on real time basis. The point is, what you do with that data, and this is where each organization, each stakeholder will determine its own way of handling it. So my views are that there is a huge scope of using various technologies like simulation technologies and data analytics, artificial intelligence, machine learning, etc., and bringing it all together at the bottom of this whole technology stack. And this is like the foundation of the building. It will govern everything. All the links of the supply chain will be governed by these technologies. I mean, this is my take.
Yeah, thank you very much, Dr. Mukherjee. So now the points that you have brought forth are very important. But if I see the conventional internal combustion engine technology as well, so if you look at the engine itself, its simulation and modeling was also a challenging task, just like the batteries we have today. So, what is the major difficulty you see in going towards digitalization in EV manufacturing? What are the major hurdles that we have to overcome compared to the conventional drivetrain technology?
It's a very important question you have asked, Professor Praveen. See, obviously the difference I see is that, see, today what is happening is that most of the, and particularly I'm talking in the context of India, the form factors are two-wheeler, three-wheeler at the moment. And mostly the OEM or makers have adopted the retrofit approach. I'm not, so it's essentially the same vehicle. So you take out the engine, take out the powertrain, put back the battery and the motor, and there you have the EV. Now, in these lower form factors, it may be okay, but the challenge here is that designing a EV from ground zero engineering approach. You have to design the complete with a complete clean sheet approach. This is where the actual engineering, your knowledge, your understanding of vehicle engineering, vehicle architecture, and the whole packaging it together in the most efficient way, safe way, is going to be tested. And this is where these technologies will be used. For example, in a car. The modern car, for example, Tesla, the whole vehicle is designed around the battery. And now skateboard platforms and other the whole new design features are coming, where they are for example, Tesla, the half of the car is like one cast, aluminum cast, die casting. I mean, this is unique. It's like the Lego structure. You just put together two halves, and now he's talking about making the full car shell, body shell, in one piece. So The point I'm making is that this is something which EV is bringing, and the challenges would be to put these things together in a way that it is all the best design or the most efficient use of the design that you can put together in an automobile.
Hmm. Okay, and then what challenges do you see in terms of the digital tools that we have for EV drivetrain or EV entire EV as such?
See, the challenges are that, there are battery specific challenges. For example, battery, the chemistry is evolving fast. Newer materials are being tested. The power density is improving, charge density is improving, the mileage, etc. So the whole, the battery ecosystem is evolving in a very rapid manner. So this is where, you got to keep up, and this is where technologies like machine learning, artificial intelligence, etc., are coming in, will come in handy, wherein huge amount of data points can be captured and they can be put together, so that you don't waste time, in doing these trial and errors. So I think the challenge, or rather the difficulties that you asked, are these related to the battery technology, because the technology itself is evolving very, very fast. Secondly, the other technologies, metal layer, hydrogen, etc., I don't know what else will come. So this is where I think the difficulty is to choose the right digital tool specific for your usage. Second is the whole powertrain. The development of motor is also changing. There are radical changes happening, rapid changes happening. Your team is doing a lot of work. I'm aware, and maybe axial motors will come, or non magnet motors are coming, etc. So I think the difficulty is to keep abreast of these technologies, happening on the hardware side, and how do the simulation tools, etc., are applied specific to these new emerging products. So I think this is where there is a bit of a lag, and as these technologies, some of these technologies will mature and become industrially scalable, we will have these digital tools and simulation tools and testing tools, etc., to back these up.
Yeah.
That's what I feel is the problem.
Okay, thank you. Thank you very much, Dr. Mukherjee, for your inputs. Now, I would request Mr. Mishra, Samir Kumar Mishra, to share his thoughts. The floor is all yours. Thank you.
Good afternoon. Thank you, Mobility Plus, Prof. Love, and the whole team members. Again, an opportunity to talk with Dr. Dev Mukherjee. We have been in one couple of panels earlier. So I'll start with Dr. Dev has gone into the design and manufacturing. I'll start a little bit off, means at the global level, then come to the design and manufacturing. So the global level, the impact of this digitization in the EV has not represented only as the you charge the electric vehicle and the work around the charging infrastructure. Rather than it is much huge utilization, like huge applications like how to buy and sell the energy transaction, trading, energy trading, and selecting a particular supplier, like lots of app has been developed, a particular energy supplier on the way, where is the energy supplier, who is the which is the charging station, all those things. These are the effective use of digitization in enabling the electric vehicle technology overall. Then the smart metering. What is the smart metering? How your per kilowatt hour vehicle consumption, how fast you are accurately measuring, and that is what being vetted by the customer itself. There will be no ambiguity of the metering, whatever you are charging from them. Then the network and connectivity, how the vehicles are connected. You have deployed 10,000 vehicles across India or globally. At sitting at one location, master control station, you can connect and you can network all the vehicles and know their status. So this is the amazing use of digitalization. Then the access of data, they like your cloud-based data, you have cloud monitoring and cloud-based applications, as well as your edge computing. Both are there. So complex tasks you can put it to the cloud-based. You can put it at the cloud-based, whereas the most critical application you can put it in edge computing, and that is the power of digitization also, as well as the payment mechanism, how the digitally payment mechanism is happening. So these are all beautification of the digitalization in the EV, which is enabling the overall EV business, and that has been effectively seen. It is not seen in the IC engine or gasoline vehicle era so far. So this is what the evolution in last couple of years, which is mostly seen in the electric vehicle technology. And these are all applications apart from the design and manufacturing, which more or less Dr. Dev has illustrated. So if I'll go a little bit deeper, like he told about the manufacturing side and the design side. So if I will illustrate the design side, like the most effective use of the design, which being a core to me, being driving the design actions at JVM. So I see the PLM, which is coming as a modern simulated PLM with latest tools. Managing the PLM through the digitization is one of the beauty of the design applications in the industry. So there itself, see example I will give. Suppose the traditional design, I will take the example as a gasoline vehicle. We are designing around the Dr. Dev told that the Tesla is designed around the battery. Similarly, suppose I will take the gasoline vehicle around one or two specific components which industry feel that it is competent enough in terms of cost, quality, time. They design the product around that, but that is the constraint when someone is interested to replace the additional components or competitive components, which is same cost or lower cost. Very difficult to go back to the design and change. It will take a complete full iteration process, maybe couple of months or a year to accommodate that. Whereas the digitization in PLM, whatever the approach we are adopting right now, most of the industries, it is a plug and play kind of things. You just have changed different components, five, six, seven components. You work around your design right from the beginning around five, six, seven components. So there will not be a risk in the supply chain side when there is a constraint in one particular component around which your production is running. So you have already things which is already fitted and plugged and played, and you just bring it and have a airdrop it in the place of this. This is the power of the PLM I am talking about, which is design. Then as it is the common things like virtual design and simulation approach, which is like the successful models like Tesla, Lucid Air, VinFast, three very successful models which has come out. And you, Professor, you cannot believe the whole automotive cycle, which takes for a gasoline vehicle is 5 to 6 years for a particular model to come up, successful model to come up. But all these vehicles which has come in 2 to 3 years with this approach of virtual simulation and design. And having said that, if anyone can browse the Lucid Air website, they have brought up almost 75 to 80% of their product design, simulation, styling, everything through virtual simulation and the design approach. So last 30% they just went and just plug and played and tested, physically tested, and they released it. So that is what the power of digitization I could see, and lots of tools. When you will go to the component level, one step lower, like the battery, motor, the charging devices, the DC-DC converter, there are lots of simulation tools like SimCat IT, Simatic IT, SimSpace, GT Suite, Console, which is a Indian version coming up very rapidly. These are being the tools which are effectively used in the industry, and these are giving amazing results. The time is reduced maybe one fourth or one third, one fourth time of the normal design cycle. Cost is optimized because you know everything where you are leading to. No one can challenge in supply chain. that this is not available, they will arm twist it, you have to bring it in a two times or three times cost. Absolutely, that is not there. And having said that, the the miniaturization of the systems you can do in the virtual simulation. Suppose you want to enhance the scope of the passenger comfort, you can miniaturize it, you can place anywhere you want. That is possible on digital approach. How many models you will build physically if you go to build in a follow the traditional approach of design like 5, 10, 20, and this is a costly solution, whereas in digitization it's a very cost effective solution. So another thing which I could see in the design, which I have known the traditional automotive things, it's called class of titans, like two titans. One is the car designer, which is styling people, another is the engineering people. So they don't see eye to eye any point of time. The styling person always says that my style is the best, and whether your design makes compromise on this or not, it hardly matters. Similarly, the approach of the engineering. So there is always a class in the traditional event because they are not sitting together. It is a serial wise sequential process. Styling will follow engineering will follow the styling, or styling will follow the engineering. Somehow it is not hand in hand. Whereas this virtual simulation and the digitalization of the design, making a platform where at the same time, same approach, remotely anyone is doing, and they are talking to each other. So there is a reduction of the class and enhancing the time to market and the quality of the product. So that is what I am seeing the power of the design. And of course, the manufacturing, like your digital twin approach, which is very prevalent now, digital twin where your product will be running, and in the cloud space, you will be running a twin system that all whatever you are doing, it is getting replicated in cloud. At any point of time, any problem in the field, you can trace back to the component level. That is the power of digitization, which was very much missing in earlier time. Then the integrated IT platform where we have the global manufacturing, like talking to each other, five different factories, they are integrated through the IT platform. So wherever the expertise is available, they can be pulled and they can be digitally talked, and the research can be utilized to enhance your product. So overall, when the industry will be taking as a platform, the handshake of the knowledge is very fast through the digitization. That is what I want to say. Then the use of artificial intelligence, which is very effective in the JVM or whatever we are using. So any advent of the problem or any advent of the situation will artificially simulate, because we know 120 parameters which is definitely going to be wrong in Indian environment when things will be operated. And then we take the worst case, then we take the best case. So we will simulate it and we will pre-program it, and there will be a by default auto diagnostic mode where some similar problems is likely to come based on the prevailing environmental scenario. So that itself will give enough hints to the back into the station that this is the problem is going to happen. So that is the power of digital application. Then machine learning, of course, your critical application in machine learning is your battery pack, where you have lots of knowledge of field test data. You bring all those data into the learning process and train the process and devise a system that if this will happen or near to that 90% of similar kind of things happen, what will be the action oriented around that. So this is how I feel the whole value system, whether it's upstream or downstream or middle stream, whole value system is getting leveraging the benefits from the digitization, and that is very powerful. And particularly because it is a high tech domain, electric vehicle, and the flexibility of using digitalization is much more than any domain which we have seen so far.
Okay, thank you. Thank you very much, Mr. Mishra. So, I would just like to ask question based on your last statement that the scope of using digitization in EV is much more than the older technologies. So, why do you think that is the case?
The reason is we have all those things which is a high tech products. It's a, like your motor you can simulate, like your DC-DC converter. You can make a 3D converter. I just 2 days before I was reading an article 3D battery. So I got surprised seeing the 3D battery. They are developing a 3D battery where you can feel real battery which is giving the power. So this is what the exact use of the digitization, when your components are digitized to a level bringing accuracy of actual running conditions in the field, 90-95% running condition. I wish it is no, not far that we will get 100% digital copy of a component in the systems, and we will just replicate it in the field, and it will be a smooth manufacturing, design and manufacturing.
Okay. Thank you. Thank you very much, Mr. Mishra. Now, I would request Mr. Bharat Krishna Rao to share his thoughts. The floor is all yours. Thank you very much.
Good afternoon, Professor. Good afternoon to my esteemed panelists and to the audience. So I think before me, Mr. Mishra ji as well as Mr. Mukherjee have given a very good understanding of how digitalization would help in the manufacturing and on the life cycle of the EV. I would like to spend a little bit of time to talk about the fundamental, I think, difference that we're seeing with EV and the relevance of EV becoming more prominent globally is the opportunity for more democratization of energy, where both the manufacturing side as well as the generation and management of the consumption of energy can be better monitored through digitalization. And specifically when you talk about the manufacturing side, uh, for something in an EV, where one of the most critical elements is, of course, the battery pack. But having traceability and a trackability of the cells from the manufacturing facility to be able to track it all the way through its life cycle, to assess its usability in different climatic conditions, altitude conditions, humidity conditions, and see its performance in different pack configurations, different form factors for different vehicle level applications, and being able to pull all of that data into a common platform where AI and ML algorithms can be put on top of that is, I think, where we will really start seeing parameters like state of health of battery packs, which today are not very accurate, becoming a lot more accurate as you see more data coming onto the platforms. And that would give us access to look at how you can really go about promoting micro factories for maybe smaller vehicles, maybe two-wheelers, could be done in microfactories. And how do you promote renewable energy generation for charging of EVs in areas where energy access is not readily available, and integrating them all into seamless platform where most most citizens of the world today are generally consumers, and very few of us are prosumers, which are producers and consumers of energy. And I think the opportunity that we see with the digitalization in the EV space is for majority of all citizens of the world to become prosumers more than just consumers, and actively participate in the transition to cleaner energy for mobility and electricity.
Okay, so thank you. Thank you very much, Mr. Rao. So, in your experience, how have you been using the digitalization concept for EV manufacturing?
Right. So we see that actually having in our BMSs, we actually track cell level voltages at individual cells, and we pull it back into a cloud-based platform to be able to monitor and also dynamically set charge discharge voltages, and testing, having a greater level of degree and control over the core systems of the battery, such as the battery management systems, as well as in the EV when you talk about the controllers and the vehicle management systems, and having all of these being able to communicate with each other in a meaningful manner would allow us to look at being able to expand at a larger and a faster pace to be able to make more micro factories viable, where the core pieces of the battery, controller, harness, charger, the core electronics of the vehicle management systems can be sort of consolidated and integrated by core OEMs, while you could have several assembly partners who could help in significantly increasing the pace of deployment of EVs into global markets, which is only possible with really integrating with digitalization right from the suppliers' facilities all the way up to the consumer's hand, and back from the consumers to second life use case applications based on the state of the battery, or being used for recycling based on the state of the battery.
Okay, yeah. Thank you. Thank you very much for your
Thank
inputs.
you.
So now I would request Mr. Patwardhan to share his thoughts. So the stage is all yours. Thank you very much.
Thank you, Professor Kumar, and uh, good afternoon to all the audience. Uh, in my opinion, actually, there is more reliance on in the EV segment compared to the internal combustion engine on digital product validation. The only reason being that all the EV platforms are not really time tested compared to the ICE engines. And if you look at the EVs, by and large, vehicle structures has really not changed. But instead of ICE powertrain, the EV powertrain has been embedded. So whatever product development that is being happening on the internal combustion engines related to structures, for example, say crash, NVH, durability, or aerodynamics, or HVAC, that will still remain same. But there are certain challenges related to EVs, like say battery thermal management, or a lot of electronics as it goes into the EV vehicles. So there is a greater concern on EMI and EMC related understanding, how the BMS and control strategy optimization need to be carried out. So in order to gauge that upfront before building the prototypes, there is more and more reliance on digital product validation. That's what my personal opinion. And whether it is really happening in that fashion, yes, there are some respectable players in the in this industry, in EV industry, who are working through simulation driven design programs, the way OEMs are doing it for internal combustion engines. But the learning curve for the EV startups compared to IC engine OEMs, I will say it is definitely has a better learning curve because of the background of the ICE powertrain, and the use of digital product validation in ICE, the same whether they are trying to use it in the EV segment as well. But still there are certain challenges, as I said, because of no data, time tested data available for certain parameters for the EV. In addition to that, my opinion is that EVs are the better candidate for the digital factories compared to the traditional factories because of Industry 4 and other kind of tools that can be employed for digital factory. The main purpose of the digital factory is basically to uh, 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 it actually validate and optimize the design of different production plants in virtual form during the planning phase itself. So a network of digital model and methods, such as say a 3D simulation tool, 3D visualization tools, that can be brought into a single umbrella, and a better integrated approach for the production that can be given. And Industry 4 actually does the same thing. It connects embedded system production technologies and smart production processes for the and actually it radically transforms, in my opinion, uh, the industry and production value chain, especially for the products that can be even applied for the IC engines. But EV are the more promising candidates for uh, industry 4 kind of applications. In We are talking about EV as a product. So in addition to the EV, there are certain auxiliary parameters which also need to be considered. For example, smart charging. So whenever a user plugs in a EV for charging, information such as charging speed and time, the charge point usage patterns, then what is the grid capacity, that actually sends to a cloud-based management platform. And this data can be further analyzed in real-time domain, and some insights can be generated efficiently to manage the grid capacity. So this is actually was not present during the ice era, so which is now feasible, and it is only possible through digitalization of, I will say, a smart charging kind of a thing. uh, Now people can even charge the cars in wireless charging fashion. Maybe some of the EV variants may be coming up with this in India, but in Europe and US, people are already experimenting this. It relies actually on resonant magnetic induction to transfer the energy between charging pad on the floor and another pad which is mounted beneath the vehicle surface. So when it is parked, say for in the parking lot, the charging can happen from say 3 kilowatt to 20 kilowatt, depending on what kind of vehicle and what is the charging rate that has been used. So over there also a lot of means this kind of technology demands more and more digitalization kind of thing. And second and the last one, what I feel where digitalization is more prominent is the IoT and cloud integration. So whenever EV charger generates massive amount of data from various sources of charging cycles, then the energy consumption, its billing, its payments, and whether there is an equipment failure to some of the charging stations. So all these data, that data analytics need to be really carried out. So IoT enabled charging apps are also there, which also contribute in enhancing the customer experience. So they will actually say that where is the nearest charging station, how much charging time will be required for your particular vehicle to charge using that charging station, and whether the equipment is good enough for your kind of charger, because now there are different charging protocols that are being used in the vehicle. So all these kind of facilities through IoT and cloud integration, that is feasible, which were not present in earlier ICE era. So I feel that there is more and more reliance on digital kind of product development, product life cycle development in the EV domain. Thanks.
Thank you very much, Mr. Patwardhan. So, one question for you: what is the single biggest advantage that you see of digitalization in EV manufacturing per se?
Yes, EV manufacturing, I will say that if you look at overall EV powertrain, there are total number of components compared to ICE engine are uh, significantly less, and these numbers can be actually catered through micro industry. And the micro industry, if you can have a more digitalized forms, it can actually cut down the time almost 10 times lesser compared to the what generally the time required for overall ICE engine manufacturing. So this I feel that because EV powertrain is just generally integrated into the vehicle. We are still there. There are still different forms of startups which are working on EV. OEMs are working on EVs, but if you look at overall EV segment and business, there are more number of startups than the actual OEMs, conventional OEMs. Those are working on in EV platform. So what startups are doing is they are more working into an integrated fashion. They are taking EV powertrain from some reputed vendor and then integrating it into their vehicle. So that kind of in that kind of scenarios, micro industries, I will say, enabled with IoT, they are more and more in numbers, they can give a better edge for faster adoption of electric mobility, especially in India.
Okay, thank you. Thank you very much for your insights. So I think we have time now for the Q&A from the audience. So Pallav, maybe we can start with the questions that the audience has for the panel.
Yes, sir. There are a few questions in the Q&A box. If you can take upon, uh,
I'll just
if
go
you
to
can
the
see the
Q&A.
Q&A box.
Yeah, I got it. Okay, so let's start with the questions. So the first question is from SPV. It's an EV startup. There is a SEMI standard for semiconductor manufacturing, which is followed by IC making fabs across the world. Does such a standard exist for EV industry in India? How is digitalization going to help EV makers stay compliant to this standard? So I think, Mr. Patwardhan, I might put this question to you.
Yes, there is a clear-cut framework given in automotive Indian standards that which means any EV from its category, whether it is a bus, truck, M or N category vehicle, it has to follow certain norms which are being notified in Central Motor Vehicle Rules and which are actually give cross references to the automotive industry standards. So there are a number of tests that are involved in right from the range, right from the batteries, motors, uh, and complete vehicle level, even including the range. So there are a number of tests that are involved in automotive industry standards. You can go through that, or you can contact me, or even in ARI website, you will be able to see the ready reckoners for two-wheelers, three-wheelers, buses, and passenger vehicles. That it has to follow which norms and which standards. If you can go through that standards and comply to those standards, it will suffice the purpose for at least for the homologation.
Okay, thank you very much. So the next question here in the Q&A box is, how can digitalization in EV manufacturing be standardized across so many different types of EV makers in India? So Dr. Mukherjee, maybe you might like to answer this.
Yeah, thank you, Professor Praveen. Uh, See, if you're talking about manufacturing process of an automobile, then the processes are essentially the same. You have to, start from the, for example, setting up the layout, the line balancing, cycle times, automation, etc. And you design your, the manufacturing line, which in case of automobile starts with the parts, then you come to the body, welding, assembly, etc. And then then there is painting, and then comes the final assembly. So these are essentially there are four sort of big manufacturing processes that any OEM follows. Now, in the form factors are different. So obviously the size, the size of the facility, the line layout, automation, etc., etc., will be different. For example, it also depends on the capacity that you're planning. For example, in case of two-wheeler, the manufacturing is quite different from of SUV, for example. Now, standardizing the processes can be done because you can simulate the entire layout of the vehicle, the manufacturing of the vehicle, and using powerful technologies like VR. Now Meta is coming, etc. So you don't have to really do much of trial and error, physically. So you can simulate everything. So that's how you can simulate a weld shop. You can also simulate a paint shop or a assembly shop or a testing shop, etc. So that is how the processes basically can be sort of standardized. Now the template will vary from company to company, from size of the industry to the size wise, also the form factor wise it will vary. But the essentially, if you are to design a welding shop for a scooter or a car, the line layout, the use of automation, robots, handling equipment, etc., these are standard tools which are available in the library. So you can pull and sort of plug and play into your design. So I think as far as the standardization is concerned on the simulation tools, yes, digitization tools, it is possible. And usually the manufacturing also follows it, but the same pattern. You have the essentially you have the input material, you process it, and you have the output. So capturing the data obviously varies from company to company, from and depends on so many things. So I think essentially the tools are available. How you use these tools for your own company or your own industry is something that you need to figure out.
Okay. Thank you very much, Dr. Mukherjee. So, Mr. Mishra, there is a question which you can help us answer. So, the question is how can it's jumping a bit too much. Yeah, how can digitalization penetrate to second tier and third tier supply chain partners as well, given the impact that they can have on overall efficiency and environmental impact?
Well, this is a very nice question actually. See, second year, third year supply chain means you mean to say when products are designed and evolved into the market in the running conditions, what will be the application wise requirements and how it will evolve through the digitalization. So that is what the thing which I told during my opening speak, that when you are designing a product, you are venturing into a domain where you have multiple flexibility. So you are catering five, six, seven, eight components. So if five, six, seven, eight components for a particular application is designed, that means the opportunity for the supply chain is already enhanced and scoped out into the design right from the beginning. So when you will come to the case that my component A, which is designed for five, six different similar components, which is available in market, is failed from one supplier, then I can go to the other supplier at any given point of time because it's a drop-in placement. It is designed all those things. So business continuity will be maintained on for the OEM as well as for the supply chain side. There will be no constraint. As well as the market side, the supplier side, there will be no constraint. So people will be evolving around. This is what indirectly answers one question about the standardization, which is being asked in the last question. So when you will say that a application wise domain is fixed through the digitalization right from the design stage. So whatever the product will be falling into that application is obviously indirectly standardized. So, irrespective of different manufacturers, irrespective of second and third years of the supply chain side constraint, whatever is being seen, that will not be a constraint at all because opportunity is there to do it, which was not there in the IC engine era. Actually, if we, the duplicate part, which is suppose the original OEM supplier part is gone wrong, duplicate part will be fitted, it will fit, and it never know in which way the overall efficiency will be impacted. You never know. You run the system, but impact will be felt some or other way. And I have seen the traditional vehicles where the mechanic will tell, sir, you have fitted this wrong component and that's why the other things have gone wrong. So better go to the OEM and feed the OEM component. So that question mark is removed in the digitization era for the EV at least.
Okay. Thank you. Thank you very much for your insights, Mr. Mishra. So I think I have a question for Mr. Rao, and I guess that would be the last question for this session. So the question is, how far has the EV industry in India adapted to digitalization, and what challenges do you foresee from IT point of view for this adoption?
Right. I think from there's a lot of scope still to be there for adoption of further digitalization. In I guess from the OEM side, each OEM has their own manufacturing process, so I would not be able to comment much on their manufacturing process. But on the actual deployment and development and usage of EVs in the current ecosystem, I think there's still a lot of scope for work in IoT based communication and integration with different members of the ecosystem, from the suppliers to the OEMs to the consumers, as well as to the end service providers, and integrating all of them onto a common platform to better understand the challenges being faced and also to be able to address those challenges in a timely manner, I think are some of the opportunities that IoTs definitely would allow us to be able to better predict the life cycles of some of the key core components and do predictive failure uh, analysis and be able to predict when the component would fail is something which can only be done as a function of data being gathered and processed through machine learning and AI algorithms as a function of big data.
Okay. Thank you. Thank you very much for your inputs. So, Mr. Rana, are we up with time or do we have some time left?
Okay, thank you very much to all of you, our esteemed panelists, for this insightful session. And I'm sure there are a lot to take away for our audience. A very special thank to Professor Probin. But before ending up the session, I would request all of you just to come up with your closing remarks. So can you start with Professor Probin?
Oh, yeah. So, my closing remark is that we have started, as a nation, we have started our journey in EV adoption and EV manufacturing. I think we should not miss the bus of the technological revolution like we did in case of ICE and then semiconductors and so on. And we should be more proactive and come up with a big portfolio of indigenous technology. Thank you.
Thank you, Professor Praveen. Can I just request Dr. Dev to come up with your closing remark, please?
Yeah, thank you, Pallab. And, as Professor Praveen pointed out, I firmly believe that we are in a very interesting times, and we are seeing this huge change in the automotive industry. This is going to have a very, very profound impact over the next 10 years. We will see, the entire energy mix will change, energy ecosystem will change. And it is a game where multiple stakeholders will have to come together, academia, industry. Typically, it has not been happening in India. Academic and researchers work in their own domain. Industry follows a separate path. So this is where I think a lot of work can be done, and a lot of these technologies can be brought to scale in industry, from the lab or the incubation to industry, and industry can really gain from this. So, I'm actually very excited. I only wish I was 25-year old, 25-year younger, to see more and more during my lifetime. But these are very interesting times, and a lot of these technologies will scale up, and we will see their application in the industry in the next few years. Thank you.
Absolutely, absolutely. Thank you for your encouraging words. So now, Mr. Bharat, please, with your closing remark.
Yes, I agree with Dr. Dev that this is
You
very
are on
exciting.
mute, sir. I believe.
Sorry. Yeah, I agree with Dr. Dev. These are very exciting times in the world today, with prominence of clean energy and net zero, clean mobility, all of this coming together, and also some of the key factors brought about by Mr. Mahesh Patwardhan, talking about the significantly lesser components in manufacturing EVs. It all together brings about some very exciting future opportunities of how humanity will move away from fossil fuels to a more sustainable means of harnessing renewables and using it for both mobility and energy. And I think this is all doable by a combination of working with academics, institutions, research institutions, OEMs, consumers, all of them coming together, which is in today's world possible with the advent of internet connectivity and 4G and 5G becoming more prominent globally. So we really look forward to this exciting new future.
Thank you very much.
Thank you.
We are all optimistic about this entire ecosystem. So we now move on to Mr. Mahesh sir with your closing remark, please.
Yeah, I will just take a thread what Mr. Rao said, that we need to reduce the dependability on the fossil fuels, and government also aims at reducing the fuel import bill and reducing the emissions, means carbon emissions, because of burning the fossil fuels. The only concern of this is that more and more fossil fuel burning happens because of HCVs, heavy commercial vehicles, passenger and goods, and majority of the passenger heavy commercial vehicles are get built in unorganized sectors on drive-away chassis. So if it is also a request from our side to all the manufacturers, like the drive-away chassis from diesel, we need to have a more and more drive-away chassis in electric EV powertrains, so that government can actually have a faster adoption of electric mobility. Its 2050 plan can also be curtailed to 2030 or 2035 if we have more and more EV drive-away chassis for HCV.
Thank you, sir. Thank you, sir. So we will wind up the session with some closing remarks from Mr. Mishra.
Well, if you'll touch base about the entire EV ecosystem, there are a lot to tell. As Dr. Dev Mukherjee has told, that is the very core topic to him and me. We used to debate in lots of forum. This industry academia handshaking is a need of the time, because we cannot survive, we cannot scale up to a level of gigawatt hour the way the other countries are going, unless until we have indigenous research and focus on that. So something which will be a need of the time, and that is definitely a push is needed from all circles to have that handshaking possible, because whatever it is designed outside, we are just adopting it, and somehow we are making a success somewhere and we are failing at other place. But if you'll do the indigenous research, which is a need of our requirement, need of our environment, and accordingly we design right from the scratch with a clean slate approach, that will be the time where after 5 years from now, we'll see that whatever we design, that is applied here with a less cost and efficient, as well as it is for India. Indigenous development, it is for India requirement. So this is the entire EV system, EV ecosystem applicable to the motor, the battery, the powertrain system, and you take the charger, whatever the things you take. This is one thing. And another thing, which is a big challenge, because I was part of the standardization committee for the last 5 years. So there is a inter fight is going on. No one is coming into a place where shaking hand each other. That this is the standard for India, where one product will be designed and across all value system or across all OEM that can be used unanimous. So that way we can reduce the cost, we can reduce the supply chain constraint, we can reduce the component requirement, all those things which is they are in existing in China. That's why they are leveraging the cost, all those things. So that standardization approach and that effort is required at a very great level, big level. Despite Niti, I have been pushing it, and lots of involvement, lots of meeting is happening each week. But coming to a point where everybody is shaking hand that this is the standard for India, this is the product for India, is yet it is yet to see the light of the day. So that approach is required. That will thereby the cost of the product and the requirement and application wise, it will be very flexible for all, not one person, but for all OEMs. Second, that is the second point. And third, I will conclude my remark with this, that the digitalization, whatever we are talking, the topic has started. So the approach is just like my analogy is just like it is a balance between heart and mind. So heart and mind, why I am talking about the balance between the heart and mind is, in the IC era, when you are thinking that the five persons are sitting in the design table across discussing, someone is discussing sun, someone is discussing moon, someone is discussing earth, all those things, but bringing that into a physical design and experimenting and bringing out a final product, It's very difficult because all those ideas cannot be put into a physical product. It is a very costly, time consuming, all those things. Whereas the reverse is applicable here. If we will talk about the emotions, which is the part of the hat used to create emotion and carry forward that feelings. Those all those practical variabilities of design. I will take the example of lucid air. All those emotions, all those feelings like aerodynamic design, aircraft type aerodynamic design, miniaturization of powertrain system to increase the passenger compartment space, then monovolume approach to maximum interior space. All those things which were dream for the IC engine era, and those dreams, which is a part of the hat, will can be digitalized and can be simulated and can be realized also, because if your one action is not venting a scope for final design, your other action may fall in place. So that is how you will make a balance between heart and mind. Your mind will say that should be less cost, less time to market, all those things. Whereas hat is selling, no, I will design a rocket in terms of the car, all those things. Everything is possible through the digitalization approach. So I will conclude my speech in line with whatever the topic has started, digitalization. So this is what my feeling is.
Thank you very much, Samisha. And thank you, all of you, our esteemed panelists, once again for this wonderful and insightful sessions. And with this, we have come to the end of this virtual event. Thank you, everyone, for extending your time and support for the event. And with a promise to come back with more exciting topics very soon, it's time to sign off. Have a wonderful weekend.
Thank you. Thank you very much. Have a good day.
Thank you.
Thank you.
Thank you. Thank you
Thank
very
you.
much.
Thank
Thank
you.
you.
Bye.
Thank you. Thank you, Pallab.